Okay, this is a harmonic drive, and this bit in the middle is the gearbox. This one can handle 3000 RPM up to about half a horsepower, and it's a 50-to-1 reduction ratio. These bits I've added just so you can demonstrate what it does, and in the previous video you can actually see how it works. Internally you've got a flexible bearing mounted on an elliptical hub. It's not really elliptical. It's like a 4-radius ellipse, so that the high points you have multiple teeth in engagement. A pure ellipse would give you single points, which is problematic. So as you rotate it, you've got 98 teeth on the flexible spline, rotating inside a 100-tooth female spline. So for every revolution you've got a 2-tooth error. So this is a 50-to-1 reduction. So if we rotate this, look at the grub screw going in the opposite direction, you can see there it goes, 50-to-1 reduction. Now in the video they do mention that these things can run with 0 backlash. That's because these things can be built to an interference fit and there is no backlash. You can literally vector a servo motor 16 bits, that's hundreds of thousands of divisions, via a 50-to-1 gearbox. What they don't mention in that video is its party piece. That's this. Most 50-to-1 gearboxes just simply will not reverse. They're below 50% efficiency and therefore they won't rotate. They just simply break. If you took a 50-to-1 worm gear, you would simply break it. This is very important in controlling high inertial loads because the motor has to control the deceleration. Whereas if you're carrying a high inertial load at below 50%, as soon as the motor tries to slow down, the system stops and the inertia takes over and breaks things. So this makes them very valuable in drives for robotics, NC work. They're quite commonplace, but very few people have seen them or understand how they work. Normally the servo motor drives this part and then the other side goes at 50-to-1 slower. So there you see it going 50-to-1 up, which is really a remarkable trick. What I did on my improbability drive was to just simply use this flexible bearing and ellipse. When you squeeze on it, you can make it rotate. So I've got an upside down or inside out radial motor using levers to squeeze it out of shape and make it rotate. And that's the trick in the drive.